let's just go in and just start implementing an array from scratch. And I'm just gonna start implementing, like, pretty much this is everything you need to know about an array. So if you just want to leave this video, go ahead. But like I mentioned before in my last video on, where was it, how to get good at LeetCode, I mentioned that not only should you be learning theory, but you should also be mixing practice with theory. That's my TLDR right there. Where is this? TLDR, mix practice with theory. So right now I just pretty much explained you all the theory and kind of diagrammed it, but let me mix some practice in with this. So basically, to practice this, what I'm going to do is actually implement an array in Python, like from scratch essentially. So let's make a class, and we'll call this ArrayList because that's pretty popular in JavaScript. Or not JavaScript, in Java. So array is just like regular array that's a fixed size, but array list actually dynamically increases. So what I said is arrays are usually a fixed size. So what I'm going to do is, like, when I create this array, def, right, there's going to be an internal array, and I'm going to give it a fixed size. I'm going to start it off with like a size of like 10. Let's say length equals 0. But in order to capture like a contiguous space of memory, I'm just going to go for I in range. Let's just grab 5 pieces of memory, and that's where I'm going to be storing my array, right? So the array length currently is 0, although like I mentioned, like we grab 5 spaces in the memory so that we can add our elements, and once we go over 5, we'll make a copy, and I'll show that right after. So it's a fixed size, takes up a contiguous space of memory. That's what I'm doing. Most languages, it's homogeneous. I don't care about that right now. Adding to an array is O of 1 amortized. So let's just like add, let's just create the function for append. Right. Like here, I can check the element is a specific data type, but like I said, I don't care if it's homogeneous or not. I doubt, I'll just trust that the developer who uses my array list uses it with good coding practices and doesn't like add whatever data type they want there. But that's like not the best thing to assume, because people just be doing random stuff, honestly. So what we're going to do, we're going to append to the array. So when we append to array, we're pretty much just going to append to like the back of always to the back of the array. So we're going to say, first we're going to check if the length, if self.array length is greater than or equal to the length. Let's just call this memory, right? So we're just simulating memory. If the array length is greater than equal to the memory that I took up, we're gonna want to make a copy. So we're gonna say self dot new memory. So like I mentioned, we're gonna find another area in the memory and try to take up a contiguous block. We'll say for I in range, the length of self.memory multiplied by 2. Right. Then I'm gonna, so now I created the new memory, but since we're at the max, I created the new memory with double the size so that I can fit all of everything from my last array, but also add the extra element that I'm looking to append. So self.new memory for I in range length of memory times 2. What are we going to do? Yeah, we're going to, for element in self dot the current memory, we're going to do, I'm going to do a enumerate here so I can grab the index. And I'm going to say self.new memory at index equals the element. So now, like here, creating copy or grabbing new portion of memory. Self.memory. Let's just do like 2 here for now. Self dot, just so we could show like how it grows, and it's gonna grow exponentially. So self dot new, we grab new memory, copy over old piece of memory, or copy over old array into memory, and at some point we're gonna take our current memory. Shouldn't probably be an instance variable. And now that's basically what an append, what's happening on an append. Yeah, new memory here. This is what I'm going to do. Else, all we're going to do is we're going to do self.memory, and then we're gonna add at the array, like the very end of the array, that element, right? And then what we're going to do is now we're going to increment the length of the array. So I'm just implementing this thing from scratch. So let's do some testing. Sorry, I'm probably just going to shrink myself here. Y'all don't really care to see me. ArrayList. So now let's test that the append function works, right? How do I... Let me print this, like... Let me look up one thing, like how to define print under method Python. Okay, I think it's this. Okay, so if we implement this function, we could define how it's implemented as string. Do the self return self.memory. Now let's just like, so now I'm building an array list in Python. You'll usually just do this, and this like a short method of actually defining the array. And then now let's just print the array. See, none, right? Now at the end array, let's like append a few values. Append a few values. Now it should have my array with A and B. Nice. Now what happens when I add C? Right? Oh shoot, I forgot to. Oh, we should do this regardless. Right here. So if the array is max capacity, we'll grow it quick, but then we'll always just add it at the end. Self.array length. Cool. Let's run this. Print array. Self.array. Okay, wait. Now I introduced the bug. Element. Okay, none. B. Print. We print the array. We do array.append C. If the array self.array length is greater than equals self.memory, we're going to take the new memory, and we're doubling it properly. And then for index in, oh shoot, Small bug there. I was that's what you call shadowing shadowing a variable. So lm here has the same value as the one here, and it kind of just like overwritten it for some reason. That's called shadowing, and you can see like when I go copy here, debugging on the fly. Cool. Now we have on our append function, right? Let's now do our remove function. Where's my water? Give me a second. Let me grab my water. Hope you all are learning something. We just did the append, and you could see why adding is O1 amortized. I mean, let's do get an index for an easy win. Say get, right? I mean, like, if the index is greater than or equal to the length raise exception, or how raise, we're doing error checking right now. Raise exception. How do I do this again? Raise exception. Index out of bounds. Self.array. What happened? If the length, if the index is greater than equal, sorry, I shouldn't have been grabbing the array length there. Otherwise, we'll just return self dot memory, and we'll return the index. Right. Let's do array. Let's do, does this work? Assert array equals you could also like throw assertion errors and stuff. Usually that's nice during an interview, to like show that you know how to do unit testing and stuff. Sorry, I'm just gonna quickly make sure my sound is working, because okay, that would be tragic if the whole time my sound is not on. So now we can get an array, an element in the array. So let's just do that exactly. Let's go print array dot get. Let's see what's on index 0. A. Let's see what's on index like 2. C. Let's see what's on index 4. It should be none, but see, index is out of bounds. All right, everything is working as we expected. Let's move fast. Removing an element, right? Where are we? Right here. Remove an element, self index. So how do we remove an element? Usually you're given an element and you want to remove, when we say element, you want to remove the first element that matches that value. First element that matches that element. So for example, if all of our elements in the array are like letters and they pass in like lm equals b, we're going to look for the first element in B and remove that. And like I mentioned, shift everything 1 over to the left and reduce like the size of the array by 1. Because now once we remove this and we move everything over, now it's size 2. So how are we going to do that? First, we're going to find like where B is in the array. And like I mentioned, that's an O of n operation to even just find that. So let's see, index of lm, right? And we'll say -1. Like we'll say this function returns -1 if it can't find anything. And then it'll, no, let's not do that. So okay, we'll say index of element is -1 for now. And we'll say for index and array element in our memory. Look, my variable names are a bit trash here, but for index in array element in my memory, what I'm going to do is I'm going to look for the first one. So like if the array element is equal to my actual element, then what I'm going to do is like index of element equals index here. Break. And you can see me using this enumerate. You can see me using this enumerate method, which is pretty handy in Python. Like, pretend I want to enumerate some like A, B, C, right? What this essentially does is it converts the array into something like this. 1. Or sorry, by it like pretty much associates each element with the index that it is. So that's very useful. If you're studying your Lee code, you better know enumerate, especially if you're using Python, because that's very much used. Index of elem equals that. And then we break out the loop, right? So if index of elem equals -1, then we return false. We'll just return a Boolean if we remove the element or not. If we true, remove false otherwise, right? So if it's -1, we return false. Otherwise, we did find the element, and all we need to do is kind of remove, like basically remove that element. And how I'm gonna do that is I'm pretty much just gonna like, if I'm deleting 3 here, what I'm gonna do is when I find the element, I'm pretty much just gonna start from that element and shift everything over 1. So this turns 4, this turns 5, right? This turns 6, this turns 7, until I get to the end of array, and then I'll just pretty much ignore that last element array and say that like and then basically say this is the end of my array now. So that's how I'm gonna remove it. Turn true here. So what I'm gonna do is like, for I in range, the index of the element, and I want to iterate until the array length. What I'll do is I'll pretty much iterate till the array length -1. And yeah, I'll be moving all the elements beside me like one. Yeah, I'll be moving all the elements beside me like 1 over. So you can do that like this. You can take the self.memory. Self.memory equals self.memory at that specific index equals self.memory I plus 1, right? At the end, we want to reduce the size of our array by 1 because we removed the element. But before that, what we're going to do is we're going to take our self.memory, and then we're just going to set the last value to literally like blank it out. So ABC, right? Now let's do array dot remove A, right? So I'm saying I'm getting index out of bounds. So what's happening here? R dot length if self dot memory. Let's do, what do we get here? Print, I'm just going to print the index of element. So if I say, where am I? Okay, so element is 0, right? So we're going to go from 0 to the length of the self.array length minus 1. Let's just print our memory out here. Did it actually do the thing that we wanted to? Interesting. Oh wait. Okay, so we're saying I'm saying I equals I plus 1. Let me quickly debug this here. So we're at 0 index and we have a plus b, right? And now we want to let's just add c too. There's an edge case here that I'm getting hit with. If you've been following my channel, I've been just getting hit with edge cases left and right. But that's just life. So ABC, we're going to remove 0. So we kind of did it, but we didn't blank out the right value. So let's do that. Okay. Cool. So I did. So let's just like make this look nicer. So we did ABC, and now we remove A, and you can see that A got popped out, and then B and all these other elements got moved over. That's essentially what removing an element from an array does. That's how you implement it. Let's see, what was that error that I was dealing with? Oh, looks like it worked now. A, B, remove A. Yeah, cool. Now let's get into the next. That literally took me 10 minutes. Now let's get into inserting an element into this data structure. Look how big this data structure is. Like, now you'll never take for granted when Python, all you have to do is that, and it creates this, and then it creates like this object that already has all that implemented. And then all you have to do is like do append and stuff. Like some engineer is maintaining that .append for you. And will be woken up on call if it doesn't work. I mean, I'm just kidding. It's a programming language, so no one's really managing it like that. Let's see. Where are we? We did append, we move, insert. So how are we going to do insert? We're going to insert at a specific index, a specific element. So pretend ABC, right? Dude, what is this thing doing? Trying to use the AI. I try not to use AI assistants when I'm studying LeetCode. So we see A, B, C, and D, right? What we're going to do next is pretty much when you do an insert, what are we going to do? We kind of have to handle the case if if it grows past the memory. So what we're going to do is let's create a function called like increase size of array. So increase, right? So this function is going to pretty much increase the size of the array if self.array length is greater than, no, we don't have to worry about that. All we need to do is like increase the size of the array. We'll do that here. I'm turning this into a reusable function so that we can eventually use it when we're dealing with inserts as well. So Let me close this down. Let's do inserting an array. Def insert self element, and I said we're gonna pass in the index and element. So what we're going to do is pretend we have like A, B, and C. Right, and I'm gonna want to insert. Pretend I want to insert. Pretend I call insert x at element 1, right? So I'm gonna insert x at element 1. That means I'm gonna insert it here, but I gotta move everything over by 1. So eventually my array should actually be like, I want to insert 1 here, and then move over B and move over C. That's my expected result, right? Let's do this. If the array size is like at its limit and we're trying to insert, we'll increase the size of the array. Like I mentioned, we'll make a copy somewhere and then move over all the elements into that copy. So what are we going to do when we do insert? We want to get that specific element in the array. So, and then move everything over. So I'm going to say like for I in range 0, or sorry, in I in range the index to the self dot array length. So array length is 0, 1. Yeah. So this gets us to the end of the array. So for I in range self dot array length here, what we're going to do is we're going to like grab a temp. Temp equals the index, or first, right? So we're going to copy like the value, and then what we're going to say is for I in range index of self dot array length, what we're going to do is, well, first we're going to want to move everything 1 over. So I guess we don't even need to capture the temp. Oh yeah, we got to capture the temp here. Pretty much, since I want to move that over, we need to capture the temp here, which is the value B. Right? And then what I'm going to do is I'm going to let's do this. We'll start at index plus 1. So we pretty much start at C. And we're pretty much looping till the end of the array. But what we're going to do is we're going to copy the one behind us to forward by 1. So let's do equals. So it's kind of the reverse of like what we did before. So we're taking the current element and then we're moving B over. Oh, but we're overwriting. Let me see. What's the best way to do that? Because now we're overwriting our value. We're saying, so pretend we had like D here. So the best way to do that is actually work backwards. So I'll say, yeah, the best way to do that is actually work backwards. So I'll start from the very end of the array, -1, to access the last element. And then I'll work my way down to the index. And I'll go reverse. This is how you go reverse down through array. And then I'll copy I into here. So I'll copy C here, right? I'll go here. Then I'll copy B. Right? And then finally, what we'll do is we'll take the self dot array self.memory at the current index, and then we're going to add the element that we want. Cool. I hope that worked. I'm just like, this is the first time I'm even doing this exercise, so I hope y'all are learning with me at the same time. So we have ABC. We're printing the array. Now let's do array.insert x. What did I say? Oh, I said the first element index. Let's say I want to insert into the first index x. Okay, it didn't copy everything over properly. Let's try this. Okay, nice. So that copied over. There might be an edge case there, honestly. I probably didn't implement like there's probably edge case there. But that's essentially what you want to do. You pretty much want to like start from the end of the array and work backwards, copying over pretty much the values over like that, and then finally insert into that index that specific element. So you can see we got the expected value there. And you have to worry about overwriting and stuff. That's why a lot of times with these array questions, if you move from the back, you could avoid like overwriting. So that's a pretty neat technique. What else? So that's insert. How do we calculate the min and the max of the array? Right. And then I'll probably end the video there. Or I'll show list comprehensions and stuff. Let's just grind through this. I can't just give up on y'all like that. I need to show y'all like pretty much all the operations. But look how much lines of code this array is already taking us, right? Now you really have to thank the Python developers for like abstracting and hiding all this away from you. So let's calculate the minimum, right? Self. When you call minimum, what is it going to do? Like min element. And the way you usually keep track of the min element is first you specify like a element that is always going, like you're always going to find an element that's smaller than that element. So usually I initialize as positive infinity because every element in the array is going to be smaller than that, right? So that's like a good way to initialize it. And I'll just say for elem in self dot for elem in range self dot array length. What I'm going to do is like if the element is less than the minimum element, that's going to be my new minimum element, right? So for the first value, let's just start giving these numbers 2, 3, 4. So for the let's do this. So for the first value 4, that's smaller than negative infinity. So my minimum element will automatically go from like, or sorry, positive infinity will go from infinity to 4, right? Then I run into 3 and I just replace that. Then I run into 2 and I kind of replace that. That's how it's gonna go. Let's do 4, 3, 1. Let's give it a weird order for now. Let's say, give me the minimum. It said none. Why is that the case? Because I didn't return my minimum element here. For elem in, oh, okay, I have to access the memory. There's not really element as index. What's happening here? Self.memory index. whatever. It's saying 1 is the smallest value. Pretend I just put like -2. Yeah, so it's calculating me my minimum function. Maximum could be calculated pretty much the same way. You can see why that's an O of n operation, because like as the array size grows, we have to look for more elements. What else? Let's just implement the max too, because I want to see how big this data structure is actually going to get. So this is going to be like a max element. Put negative here. Max element. Max element. Let's say the max here should be 4. Oops. If the self.memory is greater, sorry, I didn't flip that. Okay, 4. Let's say this one is like some huge number. So now we're grabbing the max properly. Let's do, what's a list comprehension? So list comprehension is like a way that you could like define a list like in place like this. So pretend I wanted to create a list from like a list from 0, 1, 2, 3, 4, 5, right? I can literally write it like that, but with list comprehension, I can create a list like this. 6. Look, literally created the list at the same time. And that's kind of useful when you want to build a 2D array. So pretend I have this 2D array here, like a matrix, and I want the array to kind of be a square. So to make a square, I can go like this. For a row in range, let's say I want it to, this dimension to be 5 for the square. So I'll say for row, I'm gonna build a bunch of rows, and each row is gonna be a list. And then for column in range, dimensions, right? Now I'll do for boom. So now you could see we printed out a 5 by 5 array. Wait, what the heck happened here? Sorry. And let's just put values here. So you can see now we printed out, like that's how you create like a two-dimensional array using list comprehension. So if you don't know what list comprehension, that's what it is. It's a way you can like build an array with like values in it already. Like it's basically an array constructor, and it's like, because mostly when you create array, you create array like this, or you could define like some elements, or you could like define elements using an expression. So I guess that's probably the better way. You could define an array using an expression, and it could build like more complicated arrays, like a 2D array, if you use less comprehension. I think that's pretty much everything. Oh, I forgot to add slicing the array. Let me quickly do that. Slicing array, pretty much, let's print out the array here. Right. Pretend I want to grab the 0th index to the 2nd index. To slice the array, I'm just going to do a really very basic simple one. I'll say slice self start end, right? I'll say start equals the start, like the max of start, and 0. Like I don't want you to start like beneath 0. So it's gonna try to take, if this is -3 or something, it's gonna take 0, and then like the end. This is another trick I do. Will be the min. And if they take the end, we're going to take the end is going to be the min or our self dot. What did I say is the end of the array length? So now we have start and end that's properly in the bounds. We're like with a lot of arrays, you want to do bounds checking because bounds checking will fold you in an interview if you get that wrong. So we'll say for index in range start to end, temp array, we'll say temp array dot append self dot memory index, right? Then we'll return the temp array there. Now finally let's do slice from 0 to 3. Yeah. So like I said, it's inclusive. That's why I kind of like chopped off the third element here. So 0, 1, 2, or the last, this one is exclusive, this is inclusive. Same with all the range and stuff. So that's pretty much how you implement an array from scratch. So I just want you to go and message the people who implemented Python and just be like, thank you so much for implementing me all of this functionality for free, and all I have to do is do this and I get everything for free. I'll put their link in the description. Go find them and say thank you because you just saw how much code I had to write just to get that. Imagine you had to write that all the time. But for all of you wondering like why we need classes in Python, that's exactly why. Now we have kind of like a blueprint for an array, and now we could just create these arrays whenever and they become real objects. And this video is probably over 40 minutes now. So I'll see y'all in the next video.